the grade 12s, welcome back to it. Welcome to our winter classes. It's Maths Masterclass with Leo. I am Leonard, and today we are doing November 2022. Our focus area is on number pattern and series, right? So today we'll be solving questions on number pattern and series, and these questions, they carry 24 marks. So question 2 and question 3, they carry 24 marks, right? So without any further complaints, let's get to it. Our question 2 consists of 2.1.1, and remember, reading the statement is very, very important. Always try to read the statement before you jump into solving questions, right? Let's read the question. They are saying the first term of a geometric series is 14. So I can write T1 is equals to 14, or I can say A is equals to 14, right? And then they're saying the sixth term is 448. Term number 6 of this series, T6, is equals to 448, right, for this series. So if you look at this, the first question, they're saying calculate the value of the constant ratio R. They want to know what is the value of R. They want to know what is the value of R. So in this case, that's where you apply this knowledge that we showed you in our basics to say T1 is to T2 is to T3, T4, T5, and let's end it at T6, right? So T1 is represented by what? By A, while T2 is AR, T3 AR squared, T4 is AR cubed, T5 is AR to the power 4, T6 is AR to the power 5. So in this case, I can easily say T6 is equals to AR to the power 5. Then I know what is T6. They say T6 is equals to 448. So 448 is equals to AR to the power 5. I'm looking for the value of R, but I know what is the first term. The first term in this case is represented by 14, right? A is equals to 14. I can substitute. 448 is equals to 14 R to the power 5. And then when I remove 14, this and that, they cancel. Let me try to get my calculator, see what am I getting. So when I say 448 divide 14, what do I get? I get 32. And then you can see that I'm going to need a fifth root. So fifth root of 32. 3, 2. So my R will be 2. So it means here I'm going to say 32 is equals to R to the power 5. And then when I remove this fifth, I'm going to say fifth root. And then 2 will be equals to my R. Therefore, I got the value of R as 2. That is how I can easily obtain the value of R in this question, right? Then let's go to, let's use a different color and calculate 2.1.2. 2.1.2, determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain the sum of 1146724, right? So in this case, I can easily use Sn, sum of the first nth terms. I'm looking for the sum of the first n terms. So in this case, I'm going to say Sn is equals to, because I'm dealing with a geometric, A into R to the power n minus 1 divided by R minus 1. What am I looking for? I'm looking for the value of n. So in this case, I have 114674. 114674. This is equals to, the value of A is represented by 14. Then I'll say 14 into the value of R, we got it as 2 to the power n minus 1, close bracket, divide by 2 minus 1, which this is similar to 11467 is equals to 14. Because if I say 2 minus 1 is 1, Any number divided by 1 is that number. 2 to the power n minus 1, close bracket. Then I'm going to remove this 14, divide by 14, divide by 14. This 14 and this 14, they cancel. What do I have this side? I have 2 to the power n minus 1. Let's see that side. Okay, I'm going to say 114,674 divide 14. What do I get? 8191. And then I'm going to take this to the other side. Plus 1. It's going to be 8192. And then let me look for factors of that. 2 to the power 13. Okay, in this case, it means I'm going to have 8191. Then 8191 plus 1. This is equal to 2 to the power n. And then 8192 is equal to 2 to the power n. And then from here, I can say this, it gave me 2 to the power 13. This is equal to 2 to the power n. And then n is equal to 13. But remember what they said. Determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain the sum of 114,674. So in this case, I must say n plus 6. It will give me 13, right? If I add this 6 to this consecutive number that I'm not sure of, I must get this. And I already know that the sum of the 13th terms, they give me that. So I'm going to take this to the other side and say n is equals to 13 minus 6. This gives me 7. So the number of terms that must be added in order for me to get this from 6, it should be 7 more terms. More terms must be added. Must be added. Added to the first 6 terms. Right? If I add first 6 terms on my and if I add 7 more terms on this first 6 terms, I'm gonna get 13. And 13, it is the nth term for the sum of 114,674. If I add 7 to this, I'm getting this sum of the first 13th terms, right? Which is 114,674. Right? Let's go to the next question. Which is a 2 point, use a different color, can use red, 2, 1, 3. If the first term of another series is 4, 4, 8, and the sixth term is, okay, T1 in this case is equal to 4, 4, 8, meaning A is equal to 4, 4, 8. Right? And the sixth term is 14. T6 is equal to 14. Calculate the sum of the sum to infinity of the new series, right? So the first thing, I know the formula for sum to infinity is sum to infinity. This is equal to A over 1 minus R. But this, remember, it has a condition. It works only in this condition, right? When R is in between minus 1 and 1, right? So in this case, I already know that T6 is represented by AR to the power 5, which is what I showed you in the previous slide. And then now, T6 is represented by 14, so I'll say 14 here is equals to, what am I doing? I'm looking for the value of R. I already know the value of A is 448, but I don't know the value of R for this. So 14 is AR to the power 5. And then 14 is equals to 448 r to the power 5 divide by 448 divide by 448. This and that they cancel, and then from here what will I have? From this I'm gonna have let's check the calculator. 14 divide 448 should be 1 over 32. Yes, 1 over 32 is equals to r to the power 5. And then this is like, if I say square root here or a fifth root here and fifth root there, I'm gonna get 1 over 2 is equals to my r, because this and the first one is just the switching or the changing of the your terms, right? They just changed the terms, or they changed the position of the terms. That's the only thing that they did. So it's expected for you to get 1 over 2. So in this case, I'm going to say sum of infinity is equals to A is 448 divide 1 minus into 1 over 2. This will give me what? Let's see. Should be 448 times 2. Okay, let's see. 448 divide 1 minus into 1 over 2. This is 896. 896 is my solution for that question. Hope you understand. Okay, let's try to treat the last one for question 2 and move to question 3. Hope the space will be enough. Okay, so in this case, we're given the sum of the terms, right? And we're also given Sn. What we need to calculate is the value of k. We need to identify the value of k. So how do I calculate the value of k in this case? I'm given Sn is equals to 21 over 6. If I say 20 multiply 6 plus 1, what do I get? 121. So this is similar to 121 over 6, right? What else do I have? I can get the first term, and I can clearly see that this is similar to what? Y is equals to mx plus c. This is a linear. If you can see, is 1 over 3 p plus 1 over 6. This is a linear, so I can easily use formulas for linear. The formula that I have for linear, it says Sn is equals to n over 2 into 2a plus into n minus 1 close bracket d, right? So from there, I need to calculate the first term. I need to calculate the difference, right? And from there, I already have Sn. I can calculate n and then calculate k, because k, n is equals to k plus 1, right? This is the basic formula. So in this case, I can start working with this and say, I have this. I can say 1 over 3 into 0 plus 1 over 6 is 2. 1 over 3 into 1 plus 1 over 6. And 1 over 3 into 2 plus 1 over 6. So this will give me 1 over 6 is 2. 1 over 3 plus 1 over 6 should give me, let's see, 1 over 3 plus 1 over 6. I'm getting 1 over 2. Okay, this is 1 over 2. And then last one, what do I get for the last one? This is 2 here. 5 over 6. So this is 1 over 2. And then the next one is 5 over 6. That gives me my pattern, if I'm not mistaken. And then from there, I can calculate the difference. T2 minus T1 will be my difference. And then T2, I have half minus 1 over 6. This will give me what? Half minus 1 over 6. 1 over 2 minus 1 over 6. I'm getting 1 over 3. Right? So I have the difference. I also have the first term. So I can substitute now. Substitute where? Here. And then Sn is equals to, okay, let me remove that, because I already did that there. Okay, give it some space. Sn is 121 over 6. This is equals to n, we don't know, so n over 2 into 2 into 1 over 6 plus into n minus 1 close bracket 1 over 3. And then 1 over 6 is equals to n over 2 into, this gives me 2 over 6 plus into n minus 1 close bracket 1 over 3. And then this is 1 over 6 is equals to n over 2 into, this is 1 over 3 plus 1 over 3n minus 1 over 3. This one and this one, they cancel, and then I'm left with 1 over 6 is equals to, this will be n squared over 6, and then if I cross multiply, this will give me 6 multiply 1 is equals to n squared multiply 6, and then n squared is equals to 121 square root, and then n is equals to positive 11, right? And then from there, remember this is very much important. So you'll say from there, get some space here. Okay, from there you can say n is equals to k plus 1, and then n is equals to the value of k, we don't know it, plus 1, but we know what is the value of n, which is 10, which is not 10 but 11, which is what we got just now, which is that. And then 11 minus 1 is equals to k, therefore the value of k is equals to 10, right? The value of k in this question is equals to 10. Let's move to question 3. Quickly do question 3. It's one of the easiest as well. So the first question, it is given that the general term of the quadratic number pattern is Tn, okay, 3.1, or given Tn is equals to n squared plus bn plus 9, right? And the first term of the first difference is 7. D1 is equals to 7. First term of the first difference is equals to 1, right? So in this is equals to 7. So in this case, they want us to show that b is equals to 4. So remember, 3a plus b is equals to d1. D1 of term number 1 when I use this, and then 3 into 1. Because here the value of a is represented by 1 plus, I don't know the value of b. This is equals to 7, and then b is equals to 7 minus 3. This is equals to 4. Therefore, I've showed that b is equals to 4, right? Then the next question, 3.2, they want to know, determine the value of the 60th term of this number pattern. So T60 is equals to into 60 squared. Where there's b, I know b is 4, so this will be plus 4 into 60 plus 9, right? And then let's get our solution. So in bracket, 60 squared plus 4 into 60 plus 9, 3,849. So 3,849 is my solution. 3849. It's my solution, right? Now let's go to the next question, which is 3.3, right? The next question, which is 3.3. Now 3.3, they want us to do what? Determine the general term of the sequence of the first difference of the quadratic number pattern write your answer in terms of TP is equals to MP plus Q, right? So they want the linear pattern here. Remember the first difference, it will always be the linear pattern. Your first difference is the linear pattern. So let's try to do it. This will say the first term 1 squared plus 4 into 1 plus 9 is 2. 2 squared plus 4 into 2 plus 9, and then 3 squared plus 4 into 3 plus 9, right? This is my pattern, and then let's see on my calculator what do I get. Okay, let me substitute because I already have it. This is a 1 here and 1 there. So this gives me 14, and then the second one is 2 gives me 21, third one 3 and 3, 30. Let's go to the fourth one, 4 and 4. So we have 14 is to 21 is to 30 is to 41. That is my pattern, right? This is my pattern. Now let's get the first difference. 21 minus 14, this is 7, and then 30 minus 21, this is 9, and then 41 minus 30, this is 11, right? And then let's get the difference for this. This is 2, this is 2, right? And then remember, this is a linear, so this is TP is equals to MP plus Q, right? But it comes from this. TP is equals to first term, which is A, plus into P minus 1, and then Q. And then first term in this case is 14, plus into P is represented by what? P in this case is just P minus 1, and then our difference is 2. And nope, not 14, but this, the linear one, this one, 7. Sorry for that, I made a mistake. 7. And then this will be 7 plus 2p minus 2. Then our pattern or our general term is 2p plus 5. That is our solution, right? That is our solution for this question. Let's go to the last question, 3.4. 3.4. I'm a very colorful person. I enjoy using colors. 3.4. Which two consecutive terms in the quadratic number pattern have a first difference of 157? So in this case, we use this general term, which is TP is equals to what? TP is equals to 2p plus 5. And in this case, we have this term, which is 157. This is equals to 2p plus 5. And then 157 minus 5 is equals to 2p. And then 152 is equals to 2p. If I divide this by 2, divide this by 2, I believe this will be 76 is equals to 2 is equals to p. Let me just confirm, but it is 76. 152 divided by 2, 76. Okay, then therefore p is equals to 76, right? Then those two terms, when you subtract them, they will give you this difference. It will be T76 and T77, right? That is how you're gonna do it. Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Dango means thank you. Dango!